Okay, so now we've got the issue that comes up to what if our angles aren't on our reference table? Well, in that case, they're going to end up giving you some of the values you need. So let's plug in our formulas. Sine of, this is theta, you know that word. This guy right here is mu. They are Greek letters. So when you hear me say mu, like a little kitty, mu, it's talking about this letter right here. Okay, formula says this one is sine of theta cosine of mu plus, because it's sine, the cosine of theta times the sine of mu. All right, sine of theta, I know that one. Sine of theta was -4/5 times the cosine of mu, which was -3/5, plus, ooh, I don't have anything for the cosine of theta or the sine of mu. So I'm going to have to use a little bit of the trick that we've just learned, or we can go all the way back to right triangles. Let me show you what I mean. So in the last chapter, we talked about identities, relationships between these guys. And one of them was that the cosine squared of an angle, whoops, theta, is equal to 1 minus the sine squared of theta. Now this is useful because I can plug in what I know. This right here would be -4/5 sine of theta, like they gave it to us, squared, 1 minus that, and then you can finish solving that for cosine of theta. All right. 1 minus, that's 16/25. We need a common denominator here. That'll be 25/25 minus 16/25. So we've got cosine squared of theta equals 9/25 square root, sorry, making it prettier, it's still not very pretty. So cosine of theta equals the square root of 9/25, which is the square root of 9 over square root of 25, which is 3/5. But because we took the square root right here, you can't remember, or sorry, you can't forget that there's a plus or minus out in front of there. So which one do we use? Well, that gives you more hints up here at the beginning. It says that theta is in quadrant 3. So in quadrant 3, cosine is negative. Quadrant 3 is tangent's corner, right? He gets to be positive, everybody else is negative. So it's going to be the -3/5 that we're going to shoot for. Okay, so that's one way of finding another value on there. Let me show you the other way with this sine of mu. So sine of mu. If I know that the cosine of mu is -3/5, then you can actually use right triangle trick, SOHCAHTOA, to help you find the other values. So this angle right here is mu. That would be my opposite. That's my adjacent, and this is my hypotenuse. Okay, it tells you in the problem that the cosine is -3/5. Well, 5 is the hypotenuse because it's on the bottom, and the whole thing is negative, so A we're going to consider as a negative. And I'm going to find, oh, now how do I do that? How do I find a third side when I know 2 of them? What is going on here? Help! It's like it was possessed for a minute. Okay, so we're going to find opposite using the Pythagorean theorem. So we've got, let's see. Okay, so we were going to find the opposite. We'll call that guy b. So b squared plus, we'll do a. Gotta stick with the ABCs, put them in order. So we'll do a squared plus b squared equals c squared. In this case, b is negative 3 squared equals c squared. Oops, I know what c is. Gosh, I'm tired. Imagine that. Okay, a squared plus b squared equals 5 squared. There we go. C squared, just kidding. Yeah. Okay, sorry about that. Had to go give myself a talk. Having issues. Negative 3 squared. Now that is not negative 9, it's positive 9 because the negative is inside and it's being multiplied by itself as well. Okay, finish solving. A squared equals 16 square root, and we get a equals plus or minus 4. And our c, our hypotenuse, was 5. So it could either be 4/5, or sorry, talking about the sign here. So a equals, sorry, a equals plus or minus 4, and c is 5. So if we want to find the sign of mu, since that is in, mu is in quadrant 2, which means sign is positive, and it's going to be the opposite, which is positive 4 over the hypotenuse. Okay, there is your sign of mu. So now we can plug that guy in. He is positive because sign of mu, or sorry, mu is in quadrant 2, and sign, that's his corner to be positive. Okay, and then everything else is the same. You just go through and combine stuff. Negative 4 times negative 3 is 12 over 25, plus negative 3 times 4, that's negative 12 over 25, which comes out to be 0. Okay, so now we can do cosine of theta plus u. This one's going to be even easier. It's just a formula. So cosine of theta times cosine of mu minus, because cosine's a weirdo, the sine of theta times the sine of mu, which is cosine of theta was negative 3/5 times cosine of mu, which was negative 3/5 minus sine of theta, negative 4/5 times the sine of mu, which was 4/5. So we've got negative 3 times negative 3, that's negative, nope, positive. Negative times negative is a positive. 9 over 25 minus 16 over 25. Oh, minus a negative 16 over 5, so plus 25 over 25 equals 1. Just to make sure you saw where that came from. Right here, we are subtracting right here, sorry. Subtracting a negative means to add. Okay, that was much easier now. Now you've got to do tangent. Now we don't know the tangent of each of these values, but we do know sine and cosine. So before we can start on tangent, we've got to, sorry, before we can start on the difference of the tangent of the difference, we've got to figure out the tangent of each individual one, right? So the tangent of theta, from our identities, we know that that's going to be the sine of theta over the cosine of theta. That's going to be negative 4/5 divided by negative 3/5, negative 4/5 times 5 over negative 3, which will be positive 4 over 3. That's the tangent of theta. Now the tangent of mu, you could also go over here to that right triangle, right? We know what the opposite is. So we can think of it as opposite over hypotenuse. The hypotenuse, or adjacent, my bad, sorry. So adjacent, opposite over adjacent. Okay, we know that the adjacent was negative 3. The opposite was either plus or minus 4. So since it's in quadrant 2, that means it's going to be a negative 4. And that gives us our 4/3 again. All right, same idea for tangent. Oh, just kidding, we found them both. So to find the difference, it's going to be the tangent of theta minus the tangent of mu over 1 plus tangent of theta times the tangent of mu. So tangent of theta, 4/3, minus tangent of mu, which was 4/3, times 1 plus tangent of theta, 4/3, tangent of mu, 4/3. All right. Now over here on the, oops, I forgot my divide symbol. So on top here, 4/3 minus 4/3 is 0. Divided by all this junk, right? Some stuff. But 0 divided by anything is just equal to 0. That's it.